Okay, welcome. This is lesson 9.3. Okay, we're going to move away from all the stuff we've been doing the last 2 days on metric system. We're going to move into something a little more geometric. So we're going to be talking about really 3 things today. We're going to be talking about perimeters and areas of rectangles. And then we're also going to talk about irregular shapes. And we're not going to so much talk about the perimeter of them because that's really hard. But what we will talk about is a way to find the area of strange shapes. And I have 2 guests with me today. Both Bridget and Ariana have come in and wanted to help with the video. Hope you enjoy, and let's get right into it. So let's start first with what perimeter and area mean. Okay, so perimeter is basically, if you wanted to describe it, Ariana, how would you describe the perimeter of an object? It's basically what?
It's basically the outside.
Yeah, it's the distance around the outside, okay? And that's an actual fine definition. It's the distance around the outside. Okay? Okay, now Bridget, it's your turn. What about the area of something? How would you describe the area of an object?
It's the inside of the thing.
Yeah, it's the inside measured in squares. So we're going to say the inside measured in some sort of like square tiles. Okay?
Grid.
Measured in squares. And yeah, so one of the things you could do is you could draw a grid over top of something, and you could literally kind of break it up, and you could literally count. There's a Q missing there. You could literally count how many squares it takes to fill up the object. Okay, and that's kind of a crude way to do it. We're going to learn some kind of fancy formulas for it. Now, I said we're specifically talking about the perimeter and area of a rectangle. All right, so let's draw a rectangle here. Okay, oops, that was kind of a small rectangle. Let's see, so let's erase that one. It's more a little bit bigger rectangle this time. Okay, and so let's say this perimeter, let's say this rectangle has a length or width of 2 and has a length of 5. All right, so all you have to do is add up all the sides. Well, that's only 2 of the sides. Now, it's very important that you remember that there's also going to be a 2 over here because the opposite sides are equal, and there's a 5 over here. And so you go all the way around, you add 2 plus 5 plus 2 plus 5, and you should get a perimeter of 14. Now, there is actually a cleverer way to do it. The clever way is just take one length and one width. 2 plus 5 is?
And then times, 10.
2 plus 5 is 7. Okay. 7. And then since there's another pair of them, just do what?
Double it.
Double it.
Times it by 2.
Okay, so the perimeter of a rectangle is really 2 times the length plus the width. That's the easiest formula for finding the perimeter of a rectangle. Now, the 10 was not totally wrong. What were you thinking of when you said 10, Bridget?
I was thinking of 2 times multiply 5.
And you do that when you're finding the area. So 2 times 5 would give you 10. And this would be, it's going to always be measured in units. So this one's going to be units, but it's always square units. We just said it's going to be measured in squares. Yes. Okay. And the perimeter is also going to be measured in units. So let's go back. We haven't quite finished the 14. I didn't tell you if it was centimeters or what, so we're just going to say units. So the perimeter is 14 units, no square. Okay. The area, on the other hand, is going to be units squared. All right. So that's how you find perimeter and area of a rectangle. All right, so let's go ahead and take a look at a bunch of rectangles. Here are 4 rectangles, and for each of those, what I want you to do is pause the video, and I want you to write P equals find the perimeter, and A equals find the area. Okay? Nothing to it, right? So pause the video now. Write down your answers. Let's give them. Let's actually give them names. So we'll call this one A. We'll call this one B. We'll call this one C, and we'll call this one D. Okay, so do those 4 problems, perimeter and area for each. That's a total of 8 problems. Okay, pause the video now.
Good luck.
Okay, welcome back, everybody. All right, let's go through these. The perimeter of the first one. All right, let's do these together, girls. So 4 plus 2 is?
6.
Times 2 is 12.
12.
Okay, and that's going to be units, so I'm just going to use U this time. The area, on the other hand, is 2 times 4, which is 8 units squared. Okay, and don't think that the area is smaller than the perimeter. It isn't like that. It's 2 totally different kinds of units. Okay, for letter B, it's actually a square. It's a special kind of rectangle. The perimeter for this one is 3 times plus 3 is 6. Double that, you get 12 again, and that's units. And the area is going to be 3 times 3, which is going to be 9 units squared. Now, there is another formula for a square. I'm going to put it in right here. Since the square has all sides equal, instead of adding the length and the width, since they're both the same thing, and then doubling it, we can actually just take one side and multiply by 4, because all 4 sides are the same.
Yeah.
Same thing for area. We can just take one side and multiply by itself, get side squared, and that will be the area. Okay, so that's a special. These are special formulas only for squares. All right, might as well. Might as well go ahead and talk about those. That's the next thing we're going to do. I accidentally hit the forward button. All right, the last two. What do we get for his? This is 4 plus 0.5 is 4.5. So the perimeter here is 9 units.
Oh, that's
Yeah.
0.5.
Yep, and the area is 4 times. You can think of it as a half. So 4 times a half would be 2 units squared. Okay, and finally the last one.
Yes.
The perimeter 3 plus 5 is 8. The perimeter is 16 units, and the area is 3 times 5 is 15 units squared. Okay, so that is the area and perimeter of a rectangle and also of a square. Okay, so we'll partition this off. So the square is kind of special right here. All right, finally, let's talk about finding the area of irregular shapes. Okay, here's the basic strategy for finding the area of a regular shape. First of all, you have to have it on some sort of grid. Okay, so this is already on grid paper, and what you do is you're going to take up. We're going to do this kind of the old-fashioned way. What we were just talking about, what area actually equals, we're going to count up the squares. So we're going to count up all the squares that are totally inside the figure. Then we're going to go around the outside, and we're going to count all the squares that are maybe mostly in but a little bit out, and the ones that are just a little bit in and mostly out. Okay, we're going to call those the border squares, or the boundary. Okay, and here's the deal. For the ones that are almost all in and there's probably one that's almost all out. And if you put those two together, that equals kind of one square. So what we're going to do is we're going to count up all the boundaries, and we're just going to count them all for half. That overcounts some of them and undercounts some, but it kind of balances out. So I've already done the count here. So here's a little, let's say this is a pond on a map. Okay, so what we're going to do is we're going to put all the squares that are totally, without any question, inside the red line. And it looks like there's 22 of them. Now we can argue a little bit about some of these. Like there's one right here that's a little hard to tell. Okay, maybe that one little bottom left corner is out. It doesn't really matter how exact you are. I'm going to use 22. We're not going to always get the same answers as everybody, but here's the idea. Okay, you're going to take all of the interiors, so that's 22. You're going to take all of the yellow boundaries, whether they're almost all in or almost all out, okay, and that's going to be 29. And we're going to take that, we're going to take half of those numbers, and we're going to add that up. So this is going to be, let's do this in black, this is going to equal 22 plus 14 and a half, and that'll equal 36.5. And again, I don't know really what these squares are, but we'll say units squared, and that would be the approximate. Now, I should put a wavy equals here. Okay, let me erase that. Let's make this a wavy equals. Why should it be a wavy equals, girls?
Because we don't have anything. We don't have
You're
the unit.
estimating.
Because we're estimating. This is not exact. It's like rounding. That's exactly right. Okay? And we don't know the unit either.
Yeah,
but
good
yeah,
job,
the wavy
everyone.
equals is because it is an approximation. Okay, and so that's the trick. Okay, and so we can use this to estimate all kinds of things. Now there is one little catch. If we know that the area of a square, let's say that these squares I tell you are let's say this is a map. So let's say these squares are actually 2 miles by 2 miles. This is not a pond anymore. It's actually a lake. Okay, kind of a big lake. All right, what you would do if it's that, you would take this I plus b over 2 and you would multiply the by u. And what u is, it is the area of one square. So if it's 2 by 2, the area of just one square would be 4. So basically this technique counts how many squares it takes to make the area of the figure. But if the square doesn't count as 1 by 1, then it might be important to multiply by the area of one square. And we're going to have some problems like that in the classwork tomorrow. We'll have some where the squares count 1 by 1 and some where they count 2 by 2. And if it's 2 by 2, we're obviously going to multiply by an area of 4. Okay? So girls, I thank you very much for helping out. There's their smiley faces. And so this is Mr. Gunn and Ariana and Bridget signing out 493. Thank you very much for watching our video, and we'll see you all in class tomorrow.
Adios,
Bye.
amigos.